and welcome to my channel. I am the Mad Computer Scientist. I talk about math, computer science, and tech topics that interest me. If you are new here, please take a minute to hit that like button, be sure to subscribe to the channel, and ring that notification bell. Today we're going to talk about Terrence Howard's proof that 1 times 1 equals 2. Now, I am going to be honest, this is something I've been ignoring, and this proof has been out for a while. In fact, I might not have heard about it at all if he hadn't recently come on the Joe Rogan Experience podcast, and then caught the attention of Professor Dave and several other YouTubers I follow. But his proof of 1 plus 1 equals 2 was just so delightfully wacky, I thought we could take a look at it. It is also a good experience in spotting a bad proof. Now, I will put the parts of the proof on screen that I am demonstrating for you, just so you can follow along with me and see if you can spot mistakes I didn't quite catch. Hopefully you'll be able to follow along on the screen, if not, just enlarge your screen until you can see it. So we're going to start with the title. Unbalanced equation argument 1 times 1 doesn't equal 1. It equals 2. By Terrence Howard. He goes on to say, first and foremost, let us ask the most obvious question. Is this a finished equation, yes or no? The answer is no. Let us start our forensic audit there. Why are we doing a forensic audit on a math problem? It is an incomplete equation. Why? Because it's not even on both sides. Yes, nature desires action but demands equilibrium. Therefore, in order for an equation to be finished or completed, both sides of the equation must be equally balanced. Yes, in the case of 1 times 1 equals 1, we have an unfinished equation because we have 2 1s on one side of the equation and 1 1 on the other side of the equation. Let's attempt to balance this equation by making sense of it, let's label all the relative factors. There are a couple of claims there that need to be addressed but don't necessarily require me to do a lot of excess math. The first thing is he doesn't seem to understand what a balanced equation in math is. In math, the balanced equation is just one where the left side equals the right side. And in this case, 1 times 1 on the left side does in fact equal 1. I am also not sure what Mr. Howard means by equilibrium in this particular context. Nature desires action all the time? Well, no, not always. And he really should have given a definition of equilibrium. However, he is also assuming that this equation needs to be finished and completed when it's already complete. It seems that he might not understand the rules of multiplication, but he's going to have an interesting proof, and we're going to go through that because one of the interesting things you can do when you get to higher level maths is look at bad proofs and see if you can spot the errors someone makes. And Mr. Howard makes a few here. We can already see one because he's misunderstood what a balanced equation is in math, and we can also see that he fails to understand another important concept, and that is that 1 is the identity element of multiplication. This means when you multiply any number by 1, you get that number. You don't get that number plus 1. Now let us see what happens if we want to take one item and add another one to it and see what we get. Let's see, we have 1, 2, and we have 2 groups of 1. So that means 1 times 2 is equal to 2, and because... Now let us return to Terrence Howard's proof for a second here. When last we left Mr. Howard, he was telling us that 1 times 1 equals 1 is an unfinished equation, and he was going to attempt to balance this equation. First, by making sense of it, he says, let's label the relative factors. We will call the first value of 1 A. We will call the second value of 1 B. Do you mean instances of 1? I'm not going to nitpick here. We will call the third value of 1 on the opposite side of the equation C. Terrence, let me help you here. If you're going to use something to represent the same value, you can just use A for all of them. If you use different variable names, generally that indicates a different value. After he is done creating unnecessary variable names, Mr. Howard goes on to ask us to remember the basic laws of common sense. If A times B equals C, then C must be some product of A and B. Yes, that's the way multiplication works, Mr. Howard. Yet in order for 1 times 1 to equal 1, the value of either A or B has to be missing from the final product of C. Where are we getting that from, Mr. Howard? How about we justify that and not just assume that's the case? Okay, Terrence, you are correct that if A times B equals C, then C must be a product of both A and B. That does not mean the products have to be different numbers, however. Have you forgotten what exponents are? For example, 4 can be a product of 1 and 4, but it is also a product of 2 and 2. So if we multiply 2 times 2, or take 2 to the second power, we get 4. If you're going to insist that 1 squared does not equal 1 in some new system of logic you're coming up with, you have to apply the same logic to every pattern where you're squaring a number. If I wanted to follow the pattern you already established, I would suggest 2 times 2 equals 8, where we double the square. Now I want you to pay attention to the next parts of the proof very carefully, because he does some interesting math here, and he makes up a mathematical law that, as far as I know, doesn't actually exist. So he's going to try to add 1 to both sides of the equation. It is true that whatever you do in algebra, you have to do to both sides of the equation. So he adds 1 times 1 plus 1, and he adds plus 1 to the equal side, as we can see on the screen there. However, it seems that I don't know exactly how he's decided to do that, or why, but we do get the equation he comes up with, that 1 plus 1 times 1 equals 2 if we do that, but there's no reason to do that because we don't have any variables in this equation and we're not solving for x. So he is then going on to say that if we take that equation together by his new math, we get 3 equals 2, using the associative and commutative laws. Mr. Howard, you are not applying those rules properly, nor are you applying order of operations correctly. First off, if you're going to do that, you do the 1 times 1 first, and you will get 1, not 2. Then you add 1, and you get 2. Not 3, 2. Note it's just 2. Now let us go over that law you mentioned. It doesn't actually exist. You made it up. There are 2 properties in math that have similar names, and it's the associative property and the commutative property. Multiplication and addition are both associative and commutative. Associative means you can place the braces around all addition any way you want, and it will not change the outcome. You can also do that with multiplication. Commutative means that for multiplication and addition, it doesn't matter the order you add things in. Now I want the listener to compare those properties, which I described poorly, with your description of the non-existent associative and commutative law. When a and b are positive integers, that a is to be added to itself as many times as there are units in b. Thus, 1 is added to itself 1 time, and you get 2. Now add plus 1 to the left side of the equation, and also add the plus 1 to the right side of the equation, so it gives you an answer of 3 equals 2. Now the first war machine goes on to say, that doesn't look like a balanced equation that we were looking for, does it? No, Mr. Howard, what it looks like to everyone who's paying attention so far, and who passed high school algebra, is that you can't do basic math. I applaud you for trying to come up with your own system of logic. But you have to come up with your own set of axioms rather than trying to redefine axioms that already exist. What you have done here is done addition that you didn't need to do for no reason because you weren't trying to solve for an unknown variable. Mr. Howard, I would suggest before trying to rewrite all of math, you understand basic math first. Because if you understood basic math, you would not have produced this. Let us go on to the next page of Terrence Howard's wonderful proof here. And if you take a look at his problem, you can see what he's doing wrong here. He's subtracting 1 from both sides of the equation, or at least he thinks he is, but he's misapplying order of operations because he forgets that you must do multiplication first. So, see how he has 1 times 1 set up there? He takes minus 1 under each of those, and then he subtracts 1 minus 1, gets 0, then does 0 times 1, which is 0 by the way, Mr. Howard, if you're going to do things that way, and you subtract 1 from 1 on the other side, where if you did the math the way I suggested, you would get 0 equals 0. But he, for some reason, does the subtracting for the first one and then adds 1, thus giving us 1 equals 0, which is where he's made his mistake in both of the problems he's given us. So he goes on to say, again, we have an unbalanced and unequal result. No, War Machine, what we have is someone who doesn't understand how to do basic math. It is not an uneven equation, as you put it, that we cannot call finished. It is very much finished. Let's see. It looks like Terrence Howard goes on to try some ternary C++ statements without understanding the syntax. 1 equals 0 question mark? 1 can never be equal to a 0. A no thing? I think he meant nothing. Hopefully that's just a spacing error. 3 equals 2 question mark? Nor can a 3 be equal to a 2. Also, a little programming tip here from the Mad Computer Scientist. If you're going to use ternary operators as a comparison operator, in most C-based languages you should use a double equal sign. Alright, back to Mr. Howard. Okay, let us simply apply the associative and commutative law, which you remember don't exist, to the initial equation 1 times 1 equals 1. Add A to itself as many times as indicated by units in B. Instead of applying laws that don't exist, War Machine, why don't we instead apply a principle that does exist, that 1 is the identity element of multiplication, and when you multiply any number by 1, you get that number. Thus, 1 times 1 equals 1. That way we don't have to depend on laws that we're making up. Instead, what 1 times 1 represents is how many groups of one item can we make if we only have one item. And if you try to visualize this, you'll find out, indeed, you can only get one group of one item. Alright, let's go on. And he continues, and since they are both doubling their value, then it follows that they are different expressions of the same function. But the problem is they're not doubling their value. Back to Mr. Howard, where he says, this is the point where the waves of arithmetic and waves of multiplication converge. Well, wave multiplication is a thing in math. It normally applies to sine and cosine waves. I'm not sure that waves of multiplication and waves of arithmetic exist. But if you do have more math background than I do, please let me know in the comments section. But no, 1 and 1 equals 2, and 1 times 1 equals 1 are not expressions of the same function. Mr. Howard, there is a good reason that why 1 plus 1 equals 2 and 1 times 1 equals 1 are not expressions of the same function. First of all, in order to be an expression of a function, they would have to be functions. Now, functions do have a specific definition in math, and we'll get to that just as soon as I look it up here. Give me a second. A function in mathematics is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. We can see that in your equations we don't have any variables, and therefore these are not functions. Okay, let us return to Mr. Howard's rating here. You see what happens when you follow the clear and expressed rules of the associative and commutative law that does exist? The equation is balanced on both sides of the equal sign. The only logical reason for 1 plus 1 to ever equal or to have equaled 1 is because someone forgot to follow the basic rules of multiplication. Gee, I wonder who that might have been. Otherwise, there is no way to make mathematical sense of or solve the impossible hypothesis 1 times 1 equals 1. How about applying the basic actual rules of multiplication and remembering that 1 is the identity element of multiplication? On that note, I must immediately declare that 1 times 1 equaling 1 is a false statement, and likewise based upon the current practices in the field of mathematics, 1 times any number would equal an unfinished equation because both sides of the equation could never be equal as long as 1 times 1 equals 1. If 1 times 1 equals 1, then 3 equals 2, then 1 equals 0, and a times b equals a. A times b will equal a if b equals 1 because, as stated, 1 is the identity element of multiplication. Mr. Howard then goes on to say that all of these impossible unrealities must also be inequalities, must likewise be reconsidered and relabeled as true statements. A times A equals A, B times B equals B, C times C equals C, X in parentheses times X in parentheses equals X, Y times Y equals Y, Z times Z equals Z. Well, Mr. Howard, assuming that these particular statements refer to variable names and not set names, then as long as the numbers either equal 1 or 0, these statements are indeed true. And it seems that we are done with the math on this page. Then we go into a bit of a rant. We can see that Mr. Howard tells us that he is calling on all the elementary schools, middle schools, and high schools. I call to all the nursery school teachers and kindergarten teachers, who, love teaching algebra to their kindergartners. I call upon all the schools of higher, I think he means higher, learning, and all of the thinking branches of academia, there are non-thinking branches of academia, to do an immediate audit upon this false statement of 1 plus 1 equals 1. I'm sure they'll get right on that. After thoughtful reflection and literally thousands of hours of observation coupled with 5 decades of deep and contemplative work upon the subject, it has brought me to the inevitable conclusion that this false concept must have been the brainchild of a godlike figure of some sort, someone whom the people possibly credited for giving them their multiplication table and their geometry, a gift that set civilization apart from the rest of the world. A multiplication table and system of calculating that would enable that civilization to rule then known world from the time of the late Egyptian dynasty till the Medes and the Persians brought a sudden end to their way of life. Some call them the Anunnaki, the sky people, whomever they were that gave the naive generation some 6,000 years ago a multiplication table and a flat view of universal geometry. They gave that poor misguided people a false axiom upon which to build their world. A false axiom that would behave almost as a bumper for our infantile-like species, a tutor as it were. A false axiom that would allow for a measure of growth and productivity for that civilization and would inevitably lead to failure and its inevitable collapse. I am not sure how believing that 1 times 1, an axiom that mathematicians came up with a long time ago, will lead to our inevitable collapse, but I'm sure it will have something to do with Vault-Tec dropping the bombs on October 23, 2077. I know pseudo-intellectuals like to use words like whom and whomever to sound smart, but honestly, if you're not going to use them correctly, just drop them from casual speech. Most people have done it anyway, and it's probably time to drop these words from our language. This is by far one of the strangest conspiracy theories I have ever encountered, and I'm not sure it should be part of a math proof. No one cares if you think gray aliens are giving you the answer to your algebra test. What your math teachers and professors will care about is, are you going to show your work and get the right answer? Let us return to Mr. Howard for a few seconds here. Unfortunately for the latter generations that would eventually come to inherit this once thriving Mediterranean metropolis that includes, I don't know what that is, the not-so-lucky entire world. Now, for the last 5,000 or plus years, our ancestors enslaved our thinking with that dogma, for generations upon generations leading down to our great-grandparents, who in like manner indoctrinate their children, who in turn would help through the newly formed system called tradition to propagate this false truth to the rest of the world. Geez, what other false math truths have been propagated? Maybe that 19th century Indiana dentist was right and pi is a rational number. And while the law was quickly buried by the Senate, Indiana does have the distinction of being the only state that tried to legislate the value of pi. Okay, I'm not going to continue reading more of Mr. Howard's proof here, because it goes into an unhinged conspiracy theory rant. He does get back to more math, but essentially he rewrites the 1 times table as a series of addition problems because he's assuming his initial assumption is going to be adopted by all of the brilliant mathematicians who come to recognize his genius. This video has already taken longer than I intended, and while Mr. Howard has some unique ideas about how to work math, he is going to have to do a lot more work to convince people that he's correct. While I applaud Terrence Howard's efforts for thinking about math and trying to come up with a theorem of his own, if we can call it that generously, you do have to understand a bit about math first, and he clearly does not. And while I've had some fun with the ideas of his that are clearly more unhinged, I don't want to discourage him from continuing to think about math. I just want him to learn what math actually says first before trying this. I do not know if it is true that he went to the University of South Carolina or not. I also don't know if it's true that he only has 3 more classes he needs to take to get his chemical engineering degree. However, if this is what he foisted upon his math professors, I am starting to doubt that he made it past the first semester. You can probably guess what I think of all of this judging by the tone with which I read his statements. But I want to know what you guys think. Is he onto something here? Are there ways I can prove my mathematical language to be more precise? Let me know in the comments section down below. And honestly, don't go out and make fun of him if you can find him somewhere. He is trying. He just doesn't understand the topic. And like many adults, Terrence Howard has discovered an interest in math later in life and has decided to come back to it and work on it. With that being said, go out and write some excellent code, everyone.